Hello science fans, today we're diving into something super cool and super important: motor control relays. Now, that might sound like a mouthful, but stick with me. Think about all the things around you that move thanks to electricity. Your blender, your fan, maybe even your toy car. These things use electric motors. Motors are fantastic, but they need to be told what to do. They need to be started, stopped, and sometimes even reversed. That's where control comes in. And specifically, that's where motor control relays step onto the stage, ready for action. These devices are like the traffic cops for electric motors, ensuring everything runs smoothly and safely. So what exactly is a motor control relay? Let's break it down. Motor, well, that's easy. It's the part that makes things spin or move. Think of the engine in a remote-controlled car or the part in your washing machine that tumbles your clothes. Control means we want to manage that motor. We want to tell it when to turn on, when to turn off, how fast to go, or which direction to spin. And relay? A relay is a special kind of switch. It's an electrically operated switch. Instead of you physically flipping a big handle, a small electrical signal tells the relay to do the switching for you. It's quite ingenious, really. Why are these motor control relays so important, you ask? Well, imagine trying to start a giant motor in a factory, like one that powers a huge conveyor belt. These motors can use a tremendous amount of electrical power. You wouldn't want to use a tiny little button to directly switch all that power. It could be dangerous. Sparks could fly, or the button could melt. Motor control relays allow us to use a small, safe electrical signal to control a much larger, more powerful electrical current. This makes controlling motors much safer, more efficient, and allows for all sorts of awesome automation, which is when machines do things automatically. In this guide, we're going to explore these amazing devices. We'll look at what a basic relay is, how it works its magic using principles of electromagnetism, and then how these relays become the superstars of motor control. We'll see examples from everyday life and big industries. Get ready to be electrified by knowledge, because understanding motor control relays opens up a whole world of engineering and how things work. It's going to be exciting. Consider this: you're about to become a relay expert. Let's go! Alright, before we get too deep into the motor control part, let's just talk about relays in general. What is a relay? At its heart, a relay is an electrically operated switch. Think of it like a remote control for electricity. You can use a small amount of electrical power in one circuit to control a completely separate circuit that might be handling a much larger amount of power. It's like having a very strong, invisible helper who flips a big, heavy switch for you just because you sent a tiny electrical whisper. It's a fundamental component in electrical engineering, and it's super handy. Let me give you an analogy. Imagine you want to tell a giant to lift a really heavy rock. You wouldn't shout instructions across a huge canyon, right? Maybe you'd use a small walkie-talkie. You whisper into your walkie-talkie, that's your low-power control signal. And the giant, who has the other walkie-talkie, hears you and then uses his giant muscles, that's the high-power circuit, to lift the rock. The relay is like that communication system and the giant's brain all rolled into one, translating your small instruction into a big action. It allows one electrical circuit to control another, without them being directly connected in a way that shares all the power. So, what are the key parts of a basic relay? Usually you'll find an electromagnet, which is a coil of wire that becomes a magnet when electricity flows through it. Then there's an armature, which is a movable metal piece that gets attracted by the electromagnet. A spring is often there to pull the armature back when the electromagnet is off. And crucially, there are electrical contacts. These are the parts that actually open or close to switch the second circuit on or off. These components work together in a beautifully simple way to perform a very important job in electrical systems. The most brilliant idea behind a relay is isolation. This means the circuit that's doing the controlling, the low-power one, is electrically separate from the circuit that's being controlled, the high-power one. This is super important for safety. You can keep delicate electronics like computer chips or small sensors safe from the big, potentially dangerous voltages and currents needed to run large devices. The relay acts as a bridge, but a very specific kind of bridge that keeps the two sides distinct. Safety first, science fans, and relays help us achieve that. Now for the really cool part, how does a relay actually work? The secret ingredient, the magic behind the curtain, is a wonderful scientific principle called electromagnetism. Isn't that a great word? Electromagnetism. It means that electricity and magnetism are related. Way back in the 1820s, scientists discovered that when an electric current flows through a wire, it creates a magnetic field around that wire. And if you coil that wire up, the magnetic field gets stronger. This coiled wire is what we call an electromagnet, and it's the heart of the relay. It's a magnet you can turn on and off with electricity. So, let's walk through the steps. Imagine you flip a small switch, or a sensor sends a little electrical signal. This small current flows into the relay, specifically into that coil of wire, the electromagnet. As the current flows, the coil instantly becomes a temporary magnet. It has a north pole and a south pole, just like a regular bar magnet, but only when the electricity is flowing. This is the first crucial step. The control signal energizes the coil, creating a magnetic force. It's like saying, abracadabra, become a magnet, and poof, it does. What happens next? Well, that newly formed electromagnet with its magnetic pull attracts the armature. Remember the armature? It's that movable metal piece, often made of iron or steel, positioned very close to the electromagnet. When the electromagnet turns on, its magnetic field reaches out and tugs on the armature. Click! The armature moves towards the electromagnet. This movement is the key mechanical action inside the relay. It's a tiny movement, but it has big consequences for the other circuit, the one the relay is controlling. It's a beautiful example of converting electrical energy into magnetic energy and then into mechanical motion. Now this movement of the armature is what actually does the switching. Attached to the armature, or moved by it, are the electrical contacts. These contacts are part of a completely separate electrical circuit, the one that might be connected to our motor or a big light or some other powerful device. When the armature moves, it either pushes a set of contacts together, closing the circuit and allowing power to flow, or it pulls a set of contacts apart, opening the circuit and stopping the power. So the small electrical signal in the coil makes the armature move, which then flips the switch in the high-power circuit. When the control signal stops, the current stops flowing in the coil. The electromagnet loses its magnetism, and the spring pulls the armature back to its original position, opening or closing the contacts accordingly. It's not magic, it's science, and it's elegantly simple. Okay team, we've learned about relays, these awesome electrical switches. Now let's put them together with motors. This is where things get really powerful and incredibly useful. Electric motors, as we know, are everywhere. They power everything from tiny drills to massive industrial machines. But motors, especially the bigger ones, have a characteristic. They can draw a lot of electrical current, particularly when they are just starting up. This initial surge of current is much higher than the current they use when they are running smoothly. It's like getting a heavy cart moving. It takes a big push to start, but less effort to keep it rolling. Now imagine you have a sophisticated control system, maybe run by a computer or a delicate programmable logic controller, PLC. These controllers are smart, but they are not built to handle large amounts of electrical power directly. If you tried to connect a big motor straight to the output of a small microchip, poof, you'd likely fry the chip. The chip operates on low voltages and low currents, while the motor demands high voltages and high currents. They speak different electrical languages, if you will. Trying to directly connect them is a recipe for disaster for the poor little control circuit. It's just not designed for that kind of heavy lifting. This is where our hero, the motor control relay, steps in to save the day. The relay acts as an intermediary, a translator, a strong buffer between the delicate control system and the powerful motor. The smart control system, like our PLC or microchip, sends a small, safe electrical signal to the relay's coil. This signal tells the relay, "Hey, it's time to turn the motor on," or "time to turn it off." This is a low-power conversation, perfectly safe for the controller. The relay understands this gentle instruction perfectly. The relay then takes that small instruction and performs a big action. Remember those heavy-duty contacts inside the relay? They are designed to handle the large currents and high voltages that the motor needs. So, when the relay's coil is energized by the small signal, the armature moves, and those robust contacts close, completing the circuit for the motor. Power flows, and the motor roars to life. Or if the instruction was to stop, the contacts open, cutting off the power safely. The control circuit remains protected, and the motor gets the power it needs, all thanks to the relay. Consider this. The relay is the muscular bodyguard for the brainy controller. Section 5. Controlling the power relays in action with motors. So, we know relays can turn motors on and off. But what specific jobs do motor control relays perform in the world of whirring, spinning machines? Let's get into the details. One of the most fundamental tasks is simply starting a motor. As we mentioned, motors often need a significant surge of current, called inrush current, to overcome inertia and get spinning from a standstill. A motor control relay, often called a contactor when it's designed for high power, has contacts robust enough to handle this initial jolt without welding themselves together or burning out. It ensures a reliable start every time. Beyond just starting, stopping a motor is equally critical. You need to be able to halt a motor quickly and safely. Relays excel at this. When the control signal to the relay is removed, its contacts open, cleanly breaking the power supply to the motor. This is essential not just for normal operation but also for emergency stop situations. Imagine a machine going haywire. A big red emergency stop button, when pressed, will often de-energize a relay, which in turn cuts power to the motor, potentially preventing accidents or damage. This rapid and reliable stopping capability is a huge safety feature in industrial settings. But wait, there's more. Some applications require motors to spin in one direction, and then in the opposite direction. Think about a power drill that can both screw things in and unscrew them, or an elevator that needs to go up and down. Motor control relays can be configured to achieve this motor reversal. By using a set of relays to change the way the electrical connections are made to the motor's windings, we can make it spin clockwise or counterclockwise. This is often done with two interconnected relays, ensuring that the motor isn't told to go forward and backward at the exact same time. That would be bad news. And perhaps one of the smartest jobs a relay can do for a motor is to protect it. Special types of relays, known as overload relays, are designed to sense if a motor is drawing too much current for too long. This overload condition can happen if the motor is jammed, or if it's trying to do too much work. If a motor overheats due to an overload, it can be severely damaged, or even catch fire. An overload relay monitors the current. If it gets too high, the relay trips, opening the circuit and stopping the motor before any permanent damage occurs. It's like a built-in guardian angel for your motor. How cool is that? Section 6. Everyday Heroes Relays in your home and car. You might be thinking, okay Bill, these relays sound great for big factories and complicated machines, but do I ever actually encounter them? The answer is a resounding yes. Motor control relays and relays in general are unsung heroes working silently in many devices you use every single day, especially in your car and around your home. You just might not see them because they're tucked away, doing their important jobs without any fuss. Let's pop the hood, metaphorically speaking, and find some of these hidden helpers. First up, your car. Your car is packed with relays. The most prominent one you interact with, indirectly, every time you start your vehicle is the starter solenoid. A solenoid is a type of relay. When you turn your ignition key, you're sending a small electrical current to this starter solenoid. This solenoid then closes a very heavy-duty set of contacts, allowing a massive surge of current from your car battery to flow to the starter motor. That starter motor then cranks your engine to life. Without that relay, your little ignition switch would melt trying to handle that much power. It's a perfect example of a small signal controlling a big current, but the car doesn't stop there with relays. Think about your power windows. When you press that little switch on your door, you're not directly powering the window motor. Nope, you're sending a signal to a relay, and the relay does the heavy lifting of sending power to the window motor to move it up or down. What about your headlights? Same story. A relay helps switch on those bright lights. Your car horn? Beep beep. That loud sound is often made possible because a relay is channeling the necessary power to the horn when you press the button on your steering wheel. Even the fuel pump and cooling fans in your engine often use relays. Your car is a relay festival on wheels. Now let's step into your home. While perhaps not as jam-packed with relays as your car, they are still present. Consider your refrigerator. The compressor, which is the heart of the cooling system, is a type of motor. A relay is often used to start and stop this compressor motor as needed to keep your food cold. Some air conditioning units, especially larger ones, use relays or contactors to control their powerful fan motors and compressors. Even your trusty washing machine, with its motor that spins and agitates your clothes, might have relays inside its control panel to manage the motor's operations, like switching speeds or directions. They are quietly working to make our domestic lives more convenient. Section 7. Big jobs, big relays, industries rely on them. Now that we've seen relays in our daily lives, let's scale things up and look at the world of industry. This is where motor control relays truly shine, handling enormous motors and enabling complex automated processes. In manufacturing plants, for example, you'll find countless motors. They drive conveyor belts that move products down assembly lines, power robotic arms that weld and paint, and operate massive presses that shape metal. Each of these motors needs to be controlled precisely and reliably, and that's a job tailor-made for motor control relays and their bigger cousins, contactors. These industrial motors are not just turned on and off, they are often part of intricate sequences. Imagine a bottling plant. A motor starts a conveyor, then another motor fills bottles, then another caps them, all in perfect timing. This automation is often orchestrated by PLCs, programmable logic controllers, which are like industrial computers. These PLCs send out low-voltage signals to banks of relays, and the relays then switch the power to the various motors and actuators according to the programmed sequence. Without reliable relays, these complex automated systems would grind to a halt. They are the crucial link between the brains of the operation and the brawn. Think about the buildings we work and live in, especially large commercial or public buildings. They have sophisticated HVAC systems, that's heating, ventilation, and air conditioning. These systems use very large fans to circulate air and powerful pumps to move hot or chilled water. Guess what controls these big motors? You got it, motor control relays and contactors? They ensure that these systems can turn on and off efficiently, maintaining a comfortable environment for everyone inside. The scale is impressive, the motors can be huge, and the relays that control them are built to match, ensuring durability and safety. The applications in industry are truly vast. Water treatment plants use powerful pumps, all controlled by relays, to move water through various purification stages. Power generation facilities rely on relays for controlling equipment and for protection systems. Elevators and escalators, which move people and goods vertically, depend on motor control relays for their smooth and safe operation. Even in agriculture, large irrigation pumps are often controlled by relays. It's clear that motor control relays are fundamental components that keep the wheels of industry turning, quite literally. They are the robust and reliable workhorses behind the scenes of our modern industrial landscape. Section 8: Why we love relays, the awesome benefits. So, we've journeyed through the world of motor control relays, from basic principles to diverse applications. By now you're probably thinking, wow, these relays are pretty neat, and you'd be absolutely right. But why are they so widely used? What makes them such a go-to solution for engineers and designers? Well, let's sum up the fantastic benefits that motor control relays bring to the table. First and foremost, a huge benefit is safety. This is paramount in any electrical system. Relays provide electrical isolation, meaning the low-voltage control circuit is completely separated from the high-voltage power circuit. This protects operators from dangerous shocks and safeguards sensitive control electronics from damaging high power. Another major advantage is cost-effectiveness. When it comes to switching significant amounts of electrical power, relays often provide the most economical solution. Compared to some solid-state alternatives for high-power applications, electromechanical relays can be considerably less expensive to purchase and install. Furthermore, they are generally very robust and have a long operational lifespan, especially when chosen correctly for the application. They can withstand harsh industrial environments and many switching cycles. This durability translates to lower maintenance costs and less downtime, which is always a plus in any operation, big or small. Good value for your investment is always a great thing. Then there's the incredible benefit of enabling automation. Relays are fundamental building blocks for automated systems. Because they can be controlled by low-power signals from computers, PLCs, or simple sensors, they allow us to create machines and processes that operate automatically, without constant human intervention. Think about traffic lights controlling the flow of cars, or a thermostat turning your furnace on and off. These automated actions often involve relays, switching power to motors, lights, or heaters. This automation leads to increased efficiency, productivity, and consistency in a wide range of applications, from manufacturing to building management. Relays help make our smart world possible. Finally, let's not forget simplicity and reliability. For many common switching tasks, relays are relatively simple devices to understand, implement, and troubleshoot. Their operating principle is straightforward, and their status, energized or de-energized, contacts open or closed, can often be easily determined. They are a mature, proven technology that has been refined over many decades. This inherent reliability means that when you put a relay in a circuit, you can generally trust it to do its job dependably, day in and day out. And in the world of engineering and technology, having components that just work reliably and predictably is incredibly valuable. That's why engineers keep choosing them. Section 9. Relays rock essential for our modern world. So, there you have it, science enthusiasts. We've taken a deep dive into the fascinating realm of motor control relays. These components, while sometimes small and hidden from view, play an absolutely enormous role in our electrified, automated world. They are truly fundamental building blocks that make so many other technologies possible. From the simplest task of turning on a light with a remote switch to managing the immense power needed for industrial machinery, relays are the quiet enablers, the invisible heroes working tirelessly behind the scenes. They are more than just switches, they are precision instruments of control. Think about it. Every time you start your car, use an appliance with a motor, ride an elevator, or even benefit from a product made in a modern factory, chances are a motor control relay, or several, was involved in making that happen. They provide the crucial link between low-power intelligence and high-power action, doing so safely and efficiently. Without these clever devices, controlling electric motors would be a far more cumbersome, dangerous, and expensive proposition. Our modern infrastructure, our industries, and even many of our daily conveniences would look very different and likely be far less advanced. The beauty of the relay lies in its elegant simplicity and its robust functionality. The principle of using an electromagnet to physically move contacts and switch a separate circuit is a testament to ingenious engineering. This principle has stood the test of time and continues to be relevant even in our age of high-tech electronics. While solid-state relays have their place, the classic electromechanical relay still holds strong in countless applications due to its unique advantages in cost, isolation, and power handling capabilities. It's a technology that has evolved but has never lost its core value. So the next time you hear the click of a device turning on, or see a large motor spring into action, take a moment to appreciate the mighty relay. It's a fantastic example of how basic scientific principles like electromagnetism can be harnessed to create incredibly useful and essential technology. Motor control relays are not just components, they are a cornerstone of electrical engineering, enabling safety, automation, and efficiency across the globe. They truly are an indispensable part of our technological society. Relays absolutely rock, and now you know why. Keep exploring, keep questioning, and keep discovering the science all around you.